Hey everyone. So for this project, I tackled a really interesting problem in the legal tech space. If you have ever had to read through a contract, you know how painful it is to find specific clauses like when does this contract expire? What's the governing law? It can take hours. So I thought, can we use AI to automate this? That's what this project is about. Fine tuning a language model to automatically extract key clauses from legal contracts. Let me show you what I built. All right, so first things first, the data. I'm using the CUAD dataset. The CUAD dataset stands for Contract Understanding Adequacy Dataset. It's got FITIN contracts, real commercial contracts that legal experts have already annotated. Think NDAs, distribution agreements, licensing deals, real stuff that companies actually use. Now there are like 41 different types of clauses in the contracts, but I can't tackle all of them in this project. So I picked only the six of the most important ones that lawyers care about: the governing law, the effective date, and expiration date, anti-assignment, cap on liability, and license grant. You can see these appear in like 252 3 437 contracts, so there's plenty of data to learn from here. Now here's something really important that I learned the hard way. When splitting the data for machine learning, you might think just randomly split all the examples, right? Wrong. See, each contract appears 6 times in my data set, one for each clause type I'm looking for. If I split randomly, the same contract could end up in both the training and the testing, and the model would basically be cheating. It already saw that contract text during training. So instead, I split the contract ID. Let me show you what I mean by that. So the training gets like 178 contracts. The training gets 178 contracts. The validation gets 76 contracts, and the testing gets 77. This way, when I test the model, it's seeing contracts it has genuinely never seen before. That's how it'll work in real world. Oh, and I only use 50% of the available training data because of the time and GPU constraints. Um, More on that later. Okay, so here's where things got interesting. I had to convert this into a question answering task. The model gets the contract text and a question like, where is the effective date? And it needs to point to the exact location in the text. But there's a tricky part. The data set gives me character positions, like the answer starts at character 430, but the model works with tokens, not characters. So I needed to map character positions to token maps. That's have been done in the prepositions, which you could see here, preprocessing. And here's where I hit my major bug. My initial code was finding tokens around the answers instead of tokens containing the answers. My validation loss was literally NaN, not a number, and the model couldn't learn it all. Took me a while to debug, but once I fixed the token mapping logic, boom, validation was like dropped to 1.19. The model could finally learn. This is why systematic debugging is important for me. Uh, Next, we head to the model selection. So after processing the data, we'll be going to the model selection. For the model, I went with the DistilRoBERTa. It's a smaller, faster version of the Roberta model, which we know, that keeps 97% of the performance but trains way faster. On my Kaggle GPU, training took about like 50 minutes instead of the 90 plus minutes with the full Roberta. So I had some time constraints, and I had to do it. I tested three different configurations here. First, tried with maximum length of 256 tokens, but that failed. Answers were getting cut off. Second try with 30% of the data, model couldn't learn enough. And the final version, which I have currently now, the 50% of the data and maximum length of 384. This one worked. You can see the, let me show you the training loss. You can see that the training loss had been like 0.70, and it eventually got reduced to 0.48. So that's there. And 0.70 to 0.48 it got reduced to, which means the model is learning. The validation loss went up slightly in epoch 2, suggesting a bit of overfitting, but overall, I felt it was a good progress. All right, the results. Let me come to the results. Uh, the execution is basically which happened in the Kaggle, and I'm just running it in the local, so you're just seeing the error of it. But yeah, you could see the consecutive model evaluation and the result analysis and comparison with the baseline. So let me just show you like, all right, overall the overall it was like 50%. Let me show you. Uh, these are the inference pipeline which I did, and yeah, coming to the key deliverable here. Um, Overall accuracy was like 50%. Now, before we think that it is bad, let me show you what's really interesting. Um, the effective date had come with a 67% of accuracy, um, and average answer length of 21 characters. Expiration date came with like 11% of accuracy, and average length was like 206 characters. The long clauses like anti-assignment, which had like 357 characters, only 12.5% accuracy. See the pattern, there is a strong correlation between answer length and accuracy. The model is great at finding short specific things like dates, but struggles with long multi-sentence legal clauses. um, and yeah, so um, to compare with the baseline, if I show you, yeah, um, I built this inference function as well, where you just pass in a contract and it extracts all six class types. Um, so it's processing the contract and running it through the model six times, once for each class types, and it will find the effective date with reasonable confidence for the longer clauses it's predicting, not found. And so, what does this mean in practical? For a law firm reviewing 100 contracts a month, I have a section for that as well dedicated. Here, let me just show you. For a law firm reviewing 100 contracts a month, this could save about 40 hours of manual work just on initial screening. That's like $8,000 to $15,000 in billable hours. The model development cost is just about like $50 in GPU time. It is a pretty good return of investment in my opinion, but I'm not going to pretend this is perfect. The big limitation is that 384 token limit, about 200 characters. Long legal clauses get truncated. If I were to improve this, I would like increase the context window to 512 or 768 tokens. Training on the full data set, not just 50%. And yeah, maybe try a larger model like the Roberta large or even legal BERT. And honestly, this would work best as a screening tool, not just a replacement for lawyers. It can quickly flag contracts, missing key clauses, or extract basic metadata. But you'd still want some human review for the complex stuff. So, what I learned from this project is, um, one, debugging is half the battle. That NAN issue taught me to really dig into data pre-processing. Two, bigger isn't always better. DistilRoBERTa worked great and saved me tons of time. And finally, like, understanding your model's limitation is just as important as celebrating its success. So that's the length. That's the correlation finding. Um, that's an actionable insight for future improvements in this project. I'm publishing this model to the Hugging Face as well. So if you want to try it out, built on it, like check the link in the readme.md file. All the code is in the notebook too. Yeah, and let me know your suggestions as well. Thank you.